So in today's video, we're going to be going over 2.1 quadratic functions. And, in this section, we're going to analyze graphs of quadratic functions. We're going to write quadratic functions in standard form and use the results to sketch their graph. And lastly, we're going to find minimum and maximum values of quadratic functions in real-life applications. All right, so, let's get into it. So first, what is a polynomial function? So a polynomial function is be this equation right here. I'm not going to say it because I think it's going to take too long, but some restrictions we have here is that a, subscript n cannot equal 0, and n is going to be a non-negative integer. So now, what is a quadratic function? So a quadratic function is a second-degree polynomial function, and its graph is going to be a parabola. So this is a parabola right here. It has this, sort of U shape to it. Now, a quadratic formula, or a quadratic function formula, is this right here, which is f of x equals a x to the power of 2 plus bx plus c. Now, some restrictions we have on this is that a cannot equal 0. So our next step to sort of, solving or, figuring out a quadratic function is the axis of symmetry. So an axis of symmetry is something that every quadratic function has, and it's a vertical line that goes through the graph and it's going to have a perfect reflection. So what I mean by this, let's take this parabola here. Hypothetically, we have a point here that's x equals 1, y equals 2. Our reflection on the other side, if this is our axis of symmetry, is going to be -1, x equals -1, y equals -2. But how do you find an axis of symmetry? So what we're going to do is we're going to take this formula here, which is x equals -b divided by 2a. Now, another important point of this is that wherever the axis of symmetry touches the parabola, this vertical line, that's going to be the vertex. So the vertex is going to be the point of the graph that's either the highest or the lowest. So how do you know if it's going to be the highest or lowest? So if a is greater than 0, or is a positive, then the vertex will be the lowest point. That because it's opening upwards. So the lowest point of this graph is the vertex. And if a is less than 0, or is a negative, then the vertex is going to be the highest point, because up until the vertex it's going to be a negative. It's going to peak at the vertex we have, and then it's going to go back down. So it's always going to be less than the vertex. Now, these are also known as minimum and maximum values, and in later the video we're going to go over this some more. So also another important thing to know is vertical stretch and vertical shrink. So when a is greater than 0 but less than 1, there's going to be a vertical shrink, which if, let's say this is a basic parabola, the shrink is going to be wider than this, and it's a vertical stretch. That's when a is greater than, when a is greater than 1, it's going to be a vertical stretch, which is, going to be closer than, our basic parabola here. And why is that? So let's say hypothetically we have a point here that's, x equals 2, y equals 4. And due to this vertical stretch, we're going to have a point that's x equals 1, y equals -4. So although our x value has gotten smaller, our y value has stayed the same. So basically, it's getting taller, it's stretching quicker. So that's why it's closer. Now, let's go about sketching out a graph for a quadratic function. So let's take the example here, f of x equals x squared minus 6x plus 15. So our first step is finding the axis of symmetry. So so in this equation here, our a value is going to be 1, and our b value is going to be -6. So let's take that number and plug it into our formula over here. So we're going to have minus, open parentheses, -6, close parentheses, divided by 2 times 1, which is equal to 3. Now, remember what we learned about vertex. So our step 2 is going to be finding vertex. So since we already know that our x value for the vertex is going to be 3, and we already know that a is greater than 0, so our parabola is going to be opening up towards the positive. So to find our y value, or f of x value, we're going to do f of x equals, and we're going to plug it right back into our function that we have here. So it's going to be f of 3 squared minus 6 times 3 plus 15. So let's solve that real quick. So that's going to be 9 minus 18 plus 15, which is going to be 6. So our vertex point is 3, 6, or x equals 3, y equals 6. So now let's find some other points. So step 3, find other points. So since x equals 3, y equals 6 is our vertex, or, sort of our middle ground, I'm going to take two points from before the vertex and 2 points from after the vertex. So let's start with, so I'm going to make a table real quick. So let's have that look like this. So my vertex point, and then 2 after and 2 before. So to find this, we're going to take our x values and plug it back into our formula. So basically what we did for the vertex. So this is going to be a little repetitive, but it's something we have to do. So f of x equals, so our x value here, squared minus 6 plus 15. So, 1 minus 6 plus 15. So f of x is going to equal 10. So that's our other point. And next we're going to do x equals 2. So f of x equals 2 squared minus 6 times 2 plus 15. So this is going to be equal to 4 minus 12 plus 15, which is 7. So again, we now found our second point on the graph. Next, we're going to have f of x. We're going to put the 4 in. So 4 squared minus 6 times 4 plus 15, right? So we're going to do this again. So 16, excuse me, minus 24 plus 15. So f of x is going to equal 7. Finally, we have our last number here, which is 5. So f of x equals 5 squared minus 6 times 5 plus 15, which is equal to 25 minus 30 plus 15, which is equal to 10. So as you can note, we have some of the same f of x values, and that's because of our reflection that I was talking about earlier in the video. Sorry, my pen died, so I had to replace it, and in the meantime, I graphed it. So what we have here is 1, 10, 2, 7, 3, 6, 4, 7, and then 5, 10. As you can see, our vertex here is the lowest point, and then starts reflection because, as you probably noticed, we have some of the same y values. Now, if I was smart, I would have made this graph a little bit smaller, but I didn't, so just ignore that it's kind of a very stretched out U, but it still has that U shape. So now, the next thing we're going to be learning about is how to turn a quadratic function into a standard function. So why would you do that? So it makes it easier to sort of see what the graph is doing. So standard form is going to look like this. It's going to be f of x equals a, open parentheses, x minus h squared plus k. Now, so let's break this down. So a is going to say whether it's a shrink or a stretch, and as we talked about before, if a is greater than 0 but less than 1, it's a shrink, and if it's greater than 1, it's a stretch. Now, if a is less than 0, there's a reflection in the x-axis, and then here it also tells us our vertex. Now, our vertex is going to be h and then k. And h is going to be the horizontal translation, and k is going to be the vertical translation. So basically, by turning a quadratic function into a standard form, it really just gives us a better idea of what's happening with the parabola, because you can more easily identify the points that are happening. So you can just look at this and then just understand what's going on just a little bit better than a quadratic function. Now, so how would you turn a quadratic function into standard form? So first you're going to write out the quadratic function, and in this case we're just going to do f of x equals x squared minus 4x plus 1. Now, so our a value is going to be 1, and our b value is going to be -4. So next what you're going to do is complete the square. Now, so completing the square, how do you do that? So what you're going to do is you're going to take the formula b divided by 2 and then square it. So in this case, it's going to be -4 divided by 2 squared, which is -2 squared, which is equal to 4 because -2 times -2 is 4. Now, you're going to plug this number back into our quadratic function. So we're going to have f of x plus 4, because what you do to one side, you have to do the other. And then it's going to be x squared minus 4 plus 4, close the parentheses, and then make sure you include plus 1. Now, then what you're going to do is you're going to sort of complete the square. So plus 4 equals x minus 2 squared plus 1. Now, just a little tip to have this go a little bit quicker. Whatever number you have here when you're doing the b divided by 2 squared, so after you complete the division, before you square it, if you take that number, you can just plug it straight back into here. So x minus 2, and then that's your number. It's just quicker. So now you're going to solve for x. So solve for x. So you're going to take f of x plus 4 equals x minus 2 squared plus 1. So you're going to subtract the 4, which turns into f of x. F of x equals x minus 2 squared minus 3. So this right here is standard form. Now, so now we can easily identify our vertex. So we're going to take the h and we're going to take the k. And you might be wondering, why is this 2 and not -2? So if you look here, we have -h. So a negative times a negative is a positive. So we have 2. Let's say hypothetically this was x plus 2, then our vertex here would be -2, and that's because, positive times a negative, it's going to be a negative. So now let's graph this. So similar to what we just did, we're going to just take some points. So again, let's make another table. F of x. So we're going to do 0, 1, 0, 1, 2, 3, 4. Right, okay. So our standards are going to be -3. Okay, so let's plug this back into our standard function right here. So f of x equals 0 minus 2 minus 3, which turns into -2 squared minus 3, which is 4 minus 3, which equals 1. Yeah, so our point would be 1. So we're going to add the 1 here. Next, we're going to do f of x equals 1 minus 2 squared minus 3, which is -1 squared minus 3, which is 1 minus 3, which equals -2. Again, sorry that this is very repetitive, but it is what it is, which would be -2. Right? So we're going to add the 2 here. Now we're going to move on to the points after the vertex. After the vertex. So 3 minus 2 times squared minus 3, which is 1 squared minus 3, which is equal to 1 minus 3. So again, it's 2. So now we have 3. Sorry, ignore that. -2. My bad. So fx equals 4 minus 2 squared minus 3, which turns into 2 squared minus 3, which is 4 minus 3, which is equal to 1. Again, you can see the reflection happening. So let's graph this. So our x's range from 0 to 4, and our f of x would be so anywhere from -3 to 1. Now, so right, and then we'll have this go upwards. So -3, -2, -1, 0, 1. So our first point we have is x equals 0, y equals 1. Then we have 1 equals -2. And we have 2 equals -3. We have 3 equals -2. And we have 4 equals 1. So again, we have that U shape happening. All right, so lastly, we're gonna learn about finding minimum and maximum values of quadratic functions in real life applications. So this is all gonna be hypothetical, but let's say you fired a toy rocket and it's fallen back to the ground, and you really wanna know what the maximum height it was away from the ground. So let's have a hypothetical quadratic formula, which is gonna be f of x equals -0.0050 x squared plus x plus 5. Obviously these numbers are made up. I have no idea how high a toy rocket can go or anything, so just, suspend reality for a second. So in this equation, so f of x is going to be the height of the rocket, and x is going to be the horizontal distance from the launch site. So our a is going to be this number here, the -0.0050, and our b is going to be 1. Now, to find the maximum value, we're going to use the equation -b divided by 2a, which is the same thing to find the axis of symmetry. So we're going to take our b, so -1, and divide it by our a, after we times it by 2, which is equal to 100. Now, we're going to take this 100 and plug it back into the formula. So it's going to be f of 100 equals -0.0050 times 100 to the power of 2 plus 100 plus 5. Now, so this is going to turn into f of 100 equals -0.0050 times 10,000 plus 100 plus 5. Now, all of this adds into f of 100 equals 55. So basically, x equals 100, f of x equals 55. So if we were to graph this, again, just, a fake sketch, but our point here would be 100 and then 55. So that would be our maximum distance from the ground. Now, I hope you learned something and that you enjoyed this video. That's going to be the end of 2.1 quadratic functions.